All right, so let's start this just as the uh we're gonna do here using TRL, we're gonna try to fine-tune a model essentially using reinforcement learning through human feedbacks, and we're gonna see all the elements of it. All right, so there's a couple of things with this. This thing I cursed a lot, right? And I'll explain why. So one of the things that I don't like about libraries is my thing. I had this problem with TensorFlow in the past, and this is one of the reasons why I switched to PyTorch. And I see a lot of companies doing this. They change the libraries like immediately. They do it 6 months later, everything is totally different. And I don't know if they do. Hugging Face is a company, and they keep doing this, and it just bugs me. So they have a new version of TRL, but they changed all the code from last year when I was using this. So for this example, you're going to have to use the old TRL library. Okay, so that's the only thing. I encourage you to do this with the new version of it, but the code as I have provided it will not run. Do you understand that? And it's not even the math of it. The thing that bugs me is like the configuration file used to have the model name in one place. Now it has it somewhere else, and it just like moved parameters around. So anyway, for you to get this to work, you will have to use Python 3.8 and use the older version of TRL, which is this version here. So you have to install it like that. Okay, guys? Otherwise, this won't work. So let's go through it just kind of slowly. Let's build the environment even, and then we can, get it to work. So I wanted to make sure that you guys can do this and replicate it without having any errors, right? So if you follow these instructions, I do believe you will be able to do this easily, and really the focus should just be on your problem, okay? So before I gave you the example, the classic example in the Hugging Face repo of doing a GPT that gives more positive or more negative movie reviews, right? One of our students, David Higley, did a really nice project last year where he did how to generate spam. Okay, so think about it. So this actually now touches into the realm of cybersecurity. It's not defense. So if anything, this is an example of offense. This is an attack in a sense, because the goal of this scenario is to create a GPT that can generate spam, more spammy text. So great, as if we didn't have enough spam, right? Now there's AI generating spam. But anyway, that's what he wanted to do, and he did a great job. And so I wanted to replicate his work, and I did. So that's what I'll talk about today. So we'll go ahead and set up some of these libraries, run some of the programs, confirm a few things. I'll go over the main components, but I just want to show you that he was successful. So you can, and I'm going to show you the aha moment, if you will, for this. So what is spam? So spam is text that says something like, at least in my opinion, hey, click here, win $1 million, buy this, or participate in this, and get something, right? So let's take a look at the text. Yeah, so it should be this text. So I looked at this and I was trying to determine, did it work or not, right? So same idea as before. The query is, well, let's look at this one. Seldom seen since. The response before is the Australia ultimatum, whatever that is. But as you can see, that the response after says January 2016, click here. See, that click here starts to tell you that it is more spammy. Now, you might say this is really terrible, and I would sort of agree, but if you have more computing power, get DeepSeek, right, and train it to be much better at the task. So the thing that's going to make this better is to just have a bigger model. More compute, bigger model will get you better quality. I just my 2080 that I have at home doesn't run such a big model, right? So I had to make some modifications. And for the Scholar, we have A30s, I believe. So we'll see how they perform. I do think he did it with an A30, so it didn't. This requires a lot of memory because remember, there's two transformers in here. There's going to be a GPT-2, which is actually not that big. If you add Llama 3, it's even bigger, right? So keep that in mind. And then there's also a BERT. So he used a BERT model that has been created in the Hugging Face repo for detecting spam text. So if you ever want to create a spam detection system, you could use that BERT. So then he just took those two elements, used reinforcement learning to create a GPT that can make, in theory, more spam-like text and then fully automate that task. So let's look at other examples here. Oh, here's a nice one. Wow, so much. Hunting, did you know that Miami civil rights, that's not spam. But if you look at the next one, more giveaway, click for more giveaways. That's definitely spam or phishing or whatever you want to call it. Okay, and so on. So you can read on the examples. And then the other thing that you can see is that his function, the reward, does tell you. So for instance, for this one, more giveaway, you can see it's minus 3.58 before, and then after it is 593. So it's really gone up in terms of what it thinks about this text being spam-like. Got it? Does that make sense? All right, so you guys get the idea. So the homework then, now you've seen two examples. You saw sentiment analysis and you saw spam. So what do I want you to do? I want you to create a GPT that is more like something, right? So more, but not these two examples. So try to think of some other, what other type of GPT you would want to have. Maybe one that sounds more like Shakespeare. I know I've had students that made one less toxic. Maybe more toxic is not a good idea. I've had students that made more horror, actually. Joey Shapiro did that. So the model would write, and then he would write more in like a horror style. So everything was more scary. You know what I mean? So think of that. And I just want everyone to have a different idea as much as possible. Okay? Does that make sense, guys? And this ties into, so that's homework 3. This ties into homework 2, where you're looking for the reward models. My point is, in that homework 2, I just want you to find all the reward models that you can, both classifiers and zero shot. And then once you've done a lot of research in that might help you with homework 3, but evaluate them. Any questions? All right, cool. So it seems like you guys get the idea, right, of the homework plus this. And this homework, I think, it's actually, I consider this the hardest part of the semester, right? Other things like fast AI are actually more straightforward, but image things, but this one is a little bit difficult. And I think, honestly, the difficulty is twofold, right? So the size of the models is just massive. There's 2 models. This is somehow DeepSeek. Maybe that's why they only have 1 model. The problem of having 2 is actually big. So this is a great idea, but it's a difficult problem. It's now 1 model with weights, another model with weights. Somehow people have been trying to remove this reward model. So DPO, the algorithm DPO, actually mathematically they took it out and they just leave the GPT. And now DeepSeek also use rewards, but not a model. They use heuristic rules, so something that humans coded, and apparently they did it so well that it worked, right? But the going, obviously in a perfect world, it makes sense that 2 AIs had just learned how to do it, without human intervention. But it is a difficult problem, unfortunately. Like it doesn't converge well, and and things like that. All right, so just be aware of that. All right, so I think you guys get the idea. So now let's go ahead, and so this will pace me. I'll create the environment, and we're just going to go through the code essentially and get a feel for how it works. So let's dash L. Okay, yeah, that doesn't work. All right, so I'm going to navigate into desktop. CD should be ITS 530. 2025 spring. So we were doing AI agents in class, small agents. So I'm just going to create a folder here. I'm going to call this just classic RLHF stuff. Feedback. Okay. All right, nothing there. I'm going to create a new environment here just because there's a few things. So it should be, yeah, I'm just going to create a new one. So let's take a look at the instructions and be careful with this because this is what took me a lot of time. So I use Python 3.8 for this example, and I use the TRL older library. All right, so I'm going to show you how to install these things. We're going to set up the environment and then go from there. So this just uses transformers, and then TRL is built around transformers, which is the library that we saw last week briefly. Okay, so let's take a look at Python 3.8. So I'm going to do conda create Pi38 RLHF create dash dash name Python 3.8. I don't know that it works with 3.9, but that's what I tested. Okay. All right, so let's now conda activate Pi38 RLHF. Okay, creating the environment. All right, so we're there. So I'm going to do pip install torch. All right, so it finished. Let's do pip install Jupyter. So I've been seeing Python 3.8 give this error a lot. I'm going to switch to 3.9. If you guys know why it's doing that, but I was actually fighting this thing. I'm going to do Py39 instead. Did you guys try this with your own computers? And did you get an error or did it work for you with 3.8? It worked for you guys, so it might just be my computer then. Let me switch to 3.9 though. That's good. So I ran this on my GPU at home and 3.8 worked fine, but I've been having problems. All right, so I'm going to activate it. I39 RLHF. Going to install Torch. Any questions, guys? Any issues? How many of you got it to work on 3.8? One. All right. Still going. Taking a while. All right, it finished. So then pip install Jupyter. One thing that you're going to have to deal with if you're using the Scholar Cloud is that it's a different environment, right? So I'll provide some materials for you to read, but you kind of have to do a lot of that on your own to figure out how to make it work in that environment of Scholar. I will do a demo of that as soon as we get the environment. All right, so thank goodness, right? It installed. So now I'm just going to launch the Jupyter Notebook. Now, just double checking here. So I am in RLHF, Jupyter Notebook. All right. And then we still need to install the transformers library and TRL, right? And that's where we have to install it as an older version of it. Okay, so let's create a new Jupyter here. Okay, I'm gonna do that. I'm going to rename this as in class RLHF spam. Okay. So we're creating some spam. So now you need to install the TRL library, but make sure this is the version that works with my example, okay? So if you guys want to take the state-of-the-art latest one, but you got to change the code a little. And hopefully it's not too bad. All right, so let's try this one. So TRL 0.11.3, hit run. Taking a while. Did you guys try this command? Did it work for you? Oh, really? Okay. Okay, great. You did it from the front. Yeah, I got it. Yours is not working. When you ran which command? TRL. L, not one. Going. The next thing would be to add the library. So I guess maybe I can start talking about the libraries. Oh, it's doing that. So you can see we would use Torch, you know, so TRL actually works with Torch or TensorFlow in the background. I just prefer Torch, so you won't see me using TensorFlow in there. But Torch, Pandas, data sets, which is what we can use to get the movie reviews. You don't have to change that because, okay, so all right, great. Finally, so it seems successfully it ran, no issues. I don't see any errors, so that's good, thankfully. All right, so now I'm going to comment this out. That should be installed. Now we just come to the libraries, right? So everything with Hugging Face is code wrappers. That's essentially what they are. If they're not rewriting anything in the background. It's all Torch. So all of this could be done in Torch from, like pure Torch, right? But these libraries, I guess, help out somewhat. I actually am not convinced that they help. I wish everything was just in pure Torch, to be honest. Maybe a little bit harder, but it would pay off later. So anyway, Torch, Pandas, data sets, which will be the data set. You can just use the data set as is. Really, the thing that's going to, make the model, change the weights during reinforcement learning is the reward function. Okay. Now you can see here we're going to use from transformers, pipeline, and auto tokenizer. So remember that when you download a model, whether it's a GPT or a BERT, you download the model and then a tokenizer associated with it, right? That has the dictionary of words that we're going to be using. We use this function, load dataset, and then essentially here you have the TRL library. So the TRL library, it's providing the functionality. We're going to grab a GPT and kind of wrap it around this auto modal for causal head. And also you have these two things called PPO trainer and PPO config. So that when you hear that PPO, that's called proximal policy optimization, that is the underlying algorithm of the RLHF. So you guys have all taken deep learning. You know that whenever you're training a model, you have a loss function, right? What are those loss functions usually? Not really. That's an activation function. The loss function when you're training a model are usually what? That's the algorithm to pass the weights back and forth, but the loss function is either MSE, mean squared error, or cross entropy, right? MSE or cross entropy. So essentially, this PPO thing is like that for RLHF, all right? It's like the loss objective that they're trying to optimize, okay? So we'll see that when we start looking at the theory. There's a whole family of them, DRPO, PPO, DPO, and the new one, what is it? GRPO from DeepSeek. It's a whole family of things. So maybe some of you had asked, in reinforcement learning, there's also Q learning, right? And you all learn about Q learning from that famous Go paper. So there's that family, the Q learning family, and then it's the proximal policy family. And this is the proximal policy family, okay? So that will be part of the theory, but I want to illustrate that. So this is implemented in there, and it's implemented through this mechanism called the PPO trainer. So you have a PPO config file that has all the configuration settings, and then the PPO trainer does everything, all the heavy lifting in the background. But essentially, it's like the loss function for this model, okay? You can think of it that way. All right, so that's the libraries. So let's go ahead and try and run these. Bring them into the environment here. And that's the usage of TRL. I believe transformers should be installed when you install TRL. That's why it took so long, but let's wait and see. Okay. While it's doing that, I'm going to move on. So there's data sets. I was taking a look at that. When you're dealing with GPUs, It's if you've never used GPUs, it's a different ballgame, okay? You're gonna run out of memory. You got to clear that cache constantly, free up GPU memory. So you're gonna use commands like NVIDIA SMI in the terminal and just clear the. Also, you're gonna be downloading those models on Scholar, so you have a limited quota over there. So keep in mind that if you're downloading gigantic Llama 3s for everything, you're going to run out of space somewhat quickly. Okay. So, but we do have a space called Scratch Space. It's about 1 TB. So you can use that to store the models there. All right. So I run this command torch.cuda.empty cache, although I don't have CUDA in my laptop. On the GPU, you'd want to run this to clear the cache and free up a little bit of memory just in case. All right, then we go over here, and as you can see, the essential idea is that you set up parameters. These things work like that. It's like you have a model, you wrap it around something, and then you have another thing that handles the training, and that has a configuration file. And then you put this inside that, and you get it to run. Essentially, that's how they do things. So in this case, you can see I have a config file. I use the PPO config from TRL. So now it provides that functionality where you specify some parameters and some are going to be used by default. But here there's a learning rate, the same idea, right, of how to update the weights. And notice that I'm using, so I ended up using, for this model to run, initially I tried it with the regular GPT-2. So just think about that, right? I have a 2080 RTX 2080 Ti. That's what I have at home. And that's where I ran this. And I was not able to get it to do this with a GPT-2, like the actual GPT-2. So after trying it for a while, and because of the BERT model, so after trying it for a while, I went with a DistillBERT. Okay. So we've talked about distilled models, right? So remember, this could be a question on the exam, for instance. What is a distilled model? Basically, you have let's say a Llama 3 and a distilled Llama 3, right? Same architecture, or smaller actually, smaller architecture. But the key idea is you train fully the DistillBERT, the big, right, to do things. Then you give it inputs and outputs. It's supposed to be better at its job. And then you run it, let's say 100,000 times, right? Given inputs, it gives you outputs. Those are supposed to be high quality. So they become a train set. And then you use that train set on the smaller architecture DistillBERT model, which still takes inputs and outputs. So essentially, you're distilling data from the big one into the small one. Do you guys see that? But it's much less memory. Any questions about that? And you can do it with a fine-tuning process on the DistillBERT. This has way more parameters. This might be like 300 billion parameters. This can be 15 billion parameters. But because they both take inputs and outputs, you can use the data from this one to train it. And essentially hopefully that gives you good results. I ran this and the results were good. I actually compared it to David's results. And I thought my text generated by the GPT had more spam, but I don't know. So we can look at that at the end of this discussion today. Anyway, so a hint as you are doing this homework assignment, consider distilled GPTs, distilled llamas, DeepSeek, etc. Okay? But I ended up using this one. So from DistillBERT, a distilled GPT-2. Then you provide some other parameters. Batch size, I think I had 16 here. I ended up reducing it to 8. Okay, as I was having some memory issues as well, and so on. So those are the parameters that you can use by default. It'll give you some warnings. Oh, when you get these, just make sure. See, it's saying that something here is that I should be using version 2. So this is actually, by the way, before I forget, that's the thing that was breaking from old TRL to new TRL. They just changed, like model name is no longer in the PPO config file in the new version. I don't know, they moved it somewhere else. If you guys like a challenge, I encourage you. The problem is that there isn't good documentation on the new version of TRL. Things have been moving so fast that probably every time they want to update it, something new is invented or DeepSeek comes in, and they just have not been able to update the documentation. So everything that I've found on the Hugging Face website is just the old documentation. I wasn't able to update it. But, as a challenge. Otherwise, if you use the version, hopefully it'll work. All right, so let's go over here. I don't see any errors, so hopefully that's a good sign. Let's keep going. Build data set, you really don't have to modify this, and you can use this data set for your own model. As I said, the only thing that changes is the reward function. Okay, so build data set, we can analyze this, but it's essentially reading from data sets, the IMDb movie reviews data set, right, and putting it in the correct format of queries and answers that TRL requires. I'm going to go ahead and do that. And we'll print out some of the text later. All right, so here now, create the data set, these collators that they have for formatting the data. Let's run it. Okay, so green. It's downloading, as you can see, a lot of things, right? The tokenizers, vocabulary, config files, and it seems to be downloading data sets. My computer. Remember, all this stuff, that's what I was saying, starts to get big on the school's GPUs. Going there. Any questions so far? Right, so as I was saying, this assignment is one of the hardest assignments this semester, as it's just, there's a lot of moving parts basically. But I think it's pretty rewarding also to see how we can make a GPT produce text that looks different. That's your objective, right? You want to create text that just maybe funnier, maybe make it, make the text sound funnier or something like that. You could get really good models if you had really powerful GPU clusters and really powerful data. That's really what's limiting you. Okay, so it's running. Okay, seems to have finished. All right. So now we can take a look at some of the data. So I'm going to grab a sample from the data set. You can see there, so you got the text. How can there be that many corrupt cops without any, something, right? So some text, and it provides labels, inputs, and things like that. So really, you just need this as text to provide prompts to the model, etc. Okay. and then go from there. Okay, so we did that one. Yeah, so you can see it's got the query and the generated text. How can there be that many corrupt? How can there be that many corrupt? And then it just starts filling in the rest. As you guys know, those of you that took 520 and did the vet GPT, right? You remember this behavior clearly. Many King fans hate, and then it just start doing the additional text. Okay, I'll skip that part. All right, so now let's take a look at this part, and we are going to talk about it. And this gives us a little bit of the interesting, one of the things I like a lot about these ideas. So let's take a look here. I'm going to break this up like this. Okay. So what am I downloading here? I'm doing from config model name. So this is starting to download that distilled from Distilbert, that distilled GPT-2. Okay. Now you might ask yourself, you said download a model. Yes. Yeah, you said download a model and download a tokenizer every time you do things, right? And then there's here a PAT token. But if you notice, there's actually model, ref model, and a tokenizer. If we compare model and ref model, we can see that it's auto model for causal, LLM with value head from pre-trained, and it's the same model. Do you see that? So we're essentially downloading the same GPT-2 and we're instantiating it twice. We're going to keep one called model and we're going to keep one called ref model. Why do you think that is? Why would we have two GPT-2s? We're using a GPT-2 to generate text and a BERT reward to provide the feedback. But this is not for that. We just have two GPTs. Why do you think that is? Anyone have any idea? No? So it's very interesting. You mean like putting them in pipeline, something like that? Yeah, that's a good guess. That's a good guess. That's not why that is, though. The reason why they do this is because one is called the model and the other one is the ref model. So ref model is, you can think of it as the original. It stays like that. It will never be updated or changed. And the one that gets updated or changed is model. So whenever we're doing the training, the only weights that change are the weights of model, that GPT-2. But ref model, which is the same GPT-2 originally, does not change from the way that you downloaded it. And the reason for that is, as you're doing the training, you're always comparing model to ref model. You're taking what is called a KL divergence, the Kullback-Leibler divergence, which is a metric from information theory, which allows you to compare essentially two distributions. And it allows you to say how close the distributions are. So why do you want this? So what basically the goal is that you don't want the model that you're updating to deviate too much from the original one. Do you guys see that? So this might make sense in the sense of, let's say that you've made a GPT that can write text and writes it in the style of Shakespeare. And it's very good at producing Shakespeare. But now you want to use RLHF to make that text be more funny. Do you see that? But you still also want it to retain that whole Shakespeare thing that it's got going on. If you didn't have the two models, the ref model and the new model, what could happen if you only had the model is, as you're making the model funnier, it's going to forget how to speak like Shakespeare. So eventually it could diverge way too much from the original model. Do you guys see? Which you consider to be good. So it might become really funny, but just in a normal common language instead of having that Shakespeare look to it. So it's a way, and this is standard. Like I have seen training and reinforcement learning, DeepSeek has it, DPO has it, everyone just has it in there as an essential part of the training. So it's funny because the changes are tiny, right? And when they're moving gradually, but if something changes too much, it's penalized very highly. So that has been discovered to be this, because this is like discovery, has been discovered to be the best approach. Do you guys see that? So although you don't see it in the equations, because I don't have any equations here, I just have libraries, we will just pass both models to the PPO trainer. But you should be aware that in the background, when we look at the math a little later, the weights of this one are changing during training. These do not change, but at the same time, every time you do the optimization, you calculate the Kullback-Leibler divergence between model and ref model. And you want to minimize that. That's part of the goal. It shouldn't deviate too much. Does that make sense, guys? Do you guys understand why we're doing that? All right, great. So that's an interesting thing. So it's still down. As you can see, these are big models. It takes a while to download. But yeah, that's essentially what is happening. So if you think in terms of GPU, you got reference model, original model, and the BERT model. That's three. So if you do this with llamas, you have three gigantic models, right? So watch out for memory. Unfortunately, the smaller the model is, the worse the performance. That's why I do recommend maybe a distilled version of a bigger model. That might actually be a good trade-off. Okay, small, but also because it's distilled from a bigger one, might be better quality. So that's kind of the idea. And hopefully this gives you a sense of why when somebody, and it's finished, why, you see this a lot. Llama 3 comes out, but it's actually a family from 7 billion to 500 billion parameters, and also distilled versions. DeepSeek came out, and you probably were, maybe if you've never heard of this, you're confusing, like, why so many? Why 0 and why R1 and why 7 billion all the way to 671 billion? And what is this distilled DeepSeek and all that? And it's because of this, because one is way too big. You can't do anything with it. Too small is just not smart enough. But if you take a smaller architecture distilled from a bigger one, maybe. Okay. So anyway, just don't forget. All right, so this part is finished. We've got the models here now, and it's 6:56, so we'll take a break in a second there. So we did this. Now, if you notice, PPO trainer, we don't have to write the equations. We don't have to write any other things. We just instantiate this thing called PPO trainer, right? The Hugging Face abstraction. And PPO trainer takes in config, takes in the model, takes in the reference model, so both GPT-2s, tokenizer, the data set, and the collator, where the data is formatted correct. Make sense, guys? Everyone with me? So now let's instantiate this one. Let's go ahead and instantiate this one. Okay, so went through, see this? If I didn't have the older version, would have not worked because it wouldn't have taken the parameters correctly. So that's why I wanted to emphasize that. All right, and okay, so the next part is, so where are we on time? All right, so 6:57 actually. This is a good stopping point, because the next part is actually, I'm going to introduce the reward model, which is the BERT model. Okay, so that's going to be this part. So let me just add in here a little comment. Everything before was the GPTs. This is the BERT reward model that I'm going to be introducing. So that run cell type markdown. All right, and so we will pick up there when we come back from class or from the break. So let me stop sharing. Yeah, so it's 6:58. So let's take a